Hello everyone, so welcome to my YouTube channel. In the last video we have studied about the small particles, atoms, element, molecules, compound, mixtures. Everything we have studied, and in that we have studied the definition of the matter. Then matter is classified into two, like physical and chemical. In the physical, solid, liquid and gas, and the properties of solid, properties of liquid, properties of gaseous. Then we have studied about the chemical. So chemical composition is what? Pure substances and mixture. Then we have studied about the pure substances, in that element and compound. Then we have studied about the mixture, in that homogeneous and heterogeneous. So all the things we have completed in the last video with the notes. So in today's video also we are going to start with a new and very interesting and very important topic. Okay, so topic name is atomic mass, or you can say atomic weight, or we can say relative atomic mass. Okay, now see, main thing is, now you will say that's a mass and weight, because in physics what we have studied, in physics we have studied the mass is different and weight is different, correct? In his physics what we have studied, yes, the mass is the normal and weight is what? Mass is the like normal kg, okay, and weight is what? The weight, okay. See, in the physics if you talk about the mass, so 50 kg, okay, mass means nothing but amount of the substances. But in chemistry the weight, sorry, in physics the mass and weight is different. In physics the mass and weight is different. Mass is the amount of matter, how much present in the substance, okay. Weight is the same amount of matter into gravitational force, into 9.81. okay, so this is the difference of mass and weight, because mass is the normal amount of matter which is present in the substance, is the mass, but weight is the same amount into 9.81 gravitational force. So in weight, the gravitational force, gravity will come. So that's why we used to say the mass remains same anywhere you will go, the mass will remain same. But weight keeps on changing each and every places. Why? Because mass is what? Amount of, suppose this is a pen, so mass of the pen is how much the amount of matter present inside the pen, that is the mass, correct? Suppose it is a 10 gram, so here also it is a 10 gram. If you will take and go for different planet also, it will remain 10 gram, okay, mass. Because mass is just the how much amount of matter present in this substance, that's it, that is a mass. But when we will talk about the weight, the very important thing will come under the weight is the gravitational force. That is the correct amount of matter into gravitational force. So the weight keeps on changing. In earth gravitational force is 9.81, so here the weight is different. If you will take and go the moon, their gravitational force is different, weight is different. So different places the gravitational force are different, so the weight will also differ. So in physics, this all concept what you understand, this in the physics, mass is different, weight is different. Mass is what? Amount of matter present in the substance. Weight is amount of the matter present in the substance into gravitational force, so we know the gravitational mass will remain same whole over wherever you want to, means wherever you will take and go. Weight Due to the gravitational force, the weight will keep on changing. As you will change the places like Earth, then you will go for Moon, the gravitational force will change, so weight will change. So this all in physics. Physics will say that mass and weight are different. But in chemistry we will say mass and weight both are same. In chemistry we are not applying the gravitational force and all. No. In chemistry we will say that mass and weight both are same. In chemistry what we will say? In chemistry we will say that mass and weight both are same. Remember the thing, in chemistry atomic mass, atomic weight, molecular mass, molecular weight, all are same. Mass and weight are same in chemistry, because in chemistry we are not using the gravitational force. Gravitational force is being used in the physics. So in physics mass and weight are different, but in chemistry we are not using the gravitational force, so mass and weight are same. Okay, so that's why I've written atomic mass or atomic weight or relative atomic mass. Why we are writing as relative atomic mass? So understand the concept. This concept is very very important. Okay, so relative atomic mass. Suppose you went for a like shop, vegetable shop, for purchasing 2 kgs of potato. So what you will do? You will purchase the 2 kgs of potato. Okay, suppose if the a different shopkeeper have the different weighing machine, right? Weighting machine. Some have the digital, some have the manual. So suppose in the manual you will see the 2 kg. Okay, if you want to take a 2 kg of potato, so one side it will keep the 2 kg of weight. Okay, with that weight it is giving you the potato. Means what? Relative atomic mass. See, whatever the thing we are finding atomic mass or atomic weight, it is not the exact, it will be a relative. It will be a relative, related to that it came. Because see, I like we know the SI, standard units. Okay, international system. Okay, standard units of international system, which is in America. So what happened? The America has planned all the things. Okay, like temperature. If I will ask, what is the room temperature? You will say 25 degrees Celsius or 27 degrees Celsius. What is this? Is already fixed. Okay, if I will say that, leave about that. If I will say that Celsius, you have to convert the Celsius to Kelvin. What you will do? Plus 273. Why plus 273? Yeah, this is a relative. Okay, this plus 273 will come related to something. Okay, so that's why each and everything is related to something. Okay, like suppose as we are giving the example, when you will go for a shop, so what you will see, you will go for purchasing like 2 kgs of potato. So what will happen when you will purchase a 2 kgs of potato? Simply will not give, okay, 10 piece, take and go. Okay, no, 15 pieces, take and go. Oh, you are looking very smart. 20 pieces in 2 kg. They will not say, right? Oh, you are muscular. 30 pieces in 2 kg. They will not say like that, correct? Whoever, whatever you will go, you will ask 2 kgs of potato. So what he will do? First of all, he will put one side 2 kg of weight, right? One side he will put 2 kg of weight. Then after that, next side he will put the potato according to that weight. So we don't know in 2 kg of weight how much potato will be there. So we are finding the weight of the potato relative to that 2 kg of weight. So that's why it's a relative. We are not finding the exact, means directly atomic mass. We don't know. We are finding relative to something. Okay, 2 kg. See, the 2 kg of weight, we know that iron, right? That iron, it was there. So made up of iron, the hard rod, it is like 2 kg. Okay, what we will say? Batkara. Okay, like that weight. 2 kg of weight. So 2 kg of weight, how we get to know in 2 kg of weight only 2000 gram will come? Why not 3000 gram in 2 kg? Why not 5000 gram in 2 kg? Why? Because for making that 2 kg, as I have said, international standard unit. SI unit, we have already studied SI unit, like for different thing. SI unit of mass is kg, SI unit of temperature is degree Celsius or Kelvin, SI unit of length is meter, centimeter. So this is what? This is the standard unit, international standard units. So this is the international standard units is already being measured and it is kept in the America. Okay. So based upon that international standard unit, they will give the mass for each and everything. So based upon that, we get to know that if 2 kg means 2000 gram. Okay, so if anyone person is going for purchasing the 2 kg of anything, they will put that 2 kg of weight. And then next side you have to put the vegetables or whatever the things you are purchasing or fruits. And then you will see that whether the both level are equal or not. If the both level are equal, yes, it is a 2 kg. So that's why we are taking the 2 kg of apple related to what? Related to that 2 kg of weight. Suppose you will go for purchasing the 5 kg of apple, it will put the 5 kg of weight. One side it will put the 5 kg of weight. Another side now 5 kg of apple related to that weight. So that is a relative atomic mass. For every atom, every element have their atomic mass. So that atomic mass we have not find directly that okay, suppose you woke up in the morning, oh this is what, hydrogen, oh atomic number 1, atomic mass 1. Oh what is this, oxygen, atomic number 8, oh atomic mass 16. Go. We have not did like this, right? So for each and every atomic mass we have find with relative to something. Okay, if suppose relative to something like 2 kg, 2 kg is what, 2000 gram. So this 2 kg is 2000 gram and we have seen the 2 kg of what, 2 kg of weight. It will looks like something like this. Upon this they will write the 2 kg. So 2 kg of weight they will put one side. So what is this? This is a 2 kg of weight what they will put one side. From the international standard unit they have measured like okay, 2 kg means it should be this much, 2000 gram, then only it will become 2 kg. Okay, so relative to this 2 kg what they have kept in one side, other side we have to make them both equal, right? When we'll hang, it should be both equal. Either you will take this side apples, potato, tomato, onion, anything, then we will say that this is a 2 kg of apple. How we get to know it is a 2 kg of apple? Because relative to this weight. Okay, so that's why remember the thing, it is a relative atomic mass. Atomic mass also you can say atomic weight also, but how we will find? We will find through the relative atomic mass. Now you will ask, okay, relative atomic mass we understand, but whose relative? Here we know that 2 kg of weight we have a relative, that 2 kg of weight what we will keep one side, other side we are keeping apple or potato or onion. So relative to this weight, relative to this 2 kg of weight what we are keeping on one side. Okay, but here in the atom, which relative? Okay, in the atom, which relative we will take? So we will take carbon as the relative. Okay, and see the carbon is also two types. Carbon whose atomic mass is 12, another the carbon whose atomic mass is 14. So we will not consider this. We will consider the atomic mass whose carbon whose atomic mass is 12. Okay, so now let's see. We'll write the definition. Okay, the definition for atomic mass, atomic weight, relative atomic mass, because in the examination they will ask. It indicates, it means you can say atomic mass indicates, or atomic weight indicates, or relative atomic mass indicates. It indicates how many times, it indicates how many times the mass of, it indicates how many times the mass of one atom the mass of one atom of an element, the mass of one atom of an element is heavier, in comparison. Yes, now we'll see in which comparison we will do, means in which relative we will take comparison to 1 by 12th part, 1 by 12th part of the mass of one atom of carbon 12. Okay, now see, you can write like this also, carbon 12, or you can write it this also, carbon, like this, carbon 12. Okay, now what it says, it indicates how many times the mass of one atom. If you are taking the one atom, okay, it will indicate that how many times the mass of one atom is heavier in comparison to 1 by 12th part of the mass of one atom of carbon 12. See, carbon 12 means we are taking the carbon whose atomic mass is 12. So what does this indicates? This indicates, wait a minute, what does this indicate? This indicates that we have taken a carbon, we have taken a one atom of carbon. Okay, suppose this is the one atom of carbon, this is the what, this is the one atom of carbon whose atomic mass is 12. So now what we will do, 1 by 12th part. So we took a one, what we did, we took a one atom of carbon, right? We took a one atom of carbon, in that we will do its 1/12th part, means 12th part, 1 2 3 4 5 6 7 8 9 10 then 11 12, like that. Okay, what we did, we bring the one atom of carbon. Okay, we bring the one atom of carbon, with that atom of carbon we did 12 parts. What we did, we bring one atom of carbon. Okay, one atom of carbon whose mass is 12 gram. Okay, we bring a one mass of atom. Okay, we bring a one mass of atom, and after bringing the one mass of atom, we will divide into 12 parts. Okay, we will divide into 12 parts. So when you will divide into 12 parts, we will take its one part. Okay, and then we will compare with the what, with the mass of one atom of any element. Suppose you will bring a sodium. Okay, so sodium, mass of one sodium atom. Okay, mass of one sodium atom we will compare with the 1/12th of mass of one atom of carbon. Means we will bring a one atom of carbon, we will do a 12th part. So one part of the 12th, we will compare the mass of sodium atom with one part of the 12th carbon atom. From the 12th carbon atom, we will compare a one part with the mass of sodium. So this is 1 by 12th part of carbon is a relative for other atoms mass. Okay, like as I have said you, that if you went for purchasing a 5 kg of onion, so they will put a 5 kg of weight. What they will put? 5 kg of weight. So that 5 kg of weight is what? Yeah, this is a relative. So according to this 5 kg of mass, they will give you the 5 kg of onion. So relative to which? That 5 kg of mass. Because what we will see? We will see according to this, the potato, the onion level is in same or not. If the onion, suppose this 5 kg level is more, onion level is less, so you will not take. You will say that put 1 or 2 onion, make it equal, then only I will take. So what we are doing, we are finding the mass of onion relative to that 5 kg weight. Okay, so 5 kg weight is the relative by which we are finding the 5 kg of onion. Okay, so relative to that, suppose if that weight is not there, how you will get to know that 5 kg of onion is how much? By taking in hand, you cannot able to say that okay, हाँ हो गया भाई, 5 kg of apple, go 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 go. Huh? Or you don't know the 5 kg of apple will have a 10 pieces, 12 pieces, 15 pieces, because pieces will vary. Some pieces of apple are big, some are very small, some are medium. So that's why for finding the weight of any substance, what we want the relative weight, relative mass by which we will compare this. Understand? So whenever we are going to find the atomic mass of any element, when we have to find the mass of atom, okay, mass of atom of an element, okay, so what we have to do, we have to take the relative mass. What is the relative mass? Relative mass is one piece. Okay, so one piece of 12 carbon atom, because we know what we did. We bring a carbon atom, we have cut it into the 12 pieces. We have break down the into 12 pieces. So from that one piece of 12th carbon, one piece of 12th, what is the 12th? Yes, what we have breaking down. So one piece of 12th carbon, whatever the atom we will bring for, like what we will do, we took a sodium, we'll go to the laboratory, dig 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 dig, we'll go to American laboratory, dig 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 dig, dig. We come there, okay, we like, see, this is the, I bought one sodium, find the atomic mass of sodium. So by taking in the hand, they are like, 46 gram. Someone will say no, 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 40. Someone will fight for 50. So what is this? When we will take and go for sodium, they will bring the relative mass. Relative mass is what? Yes, they will bring the what? They have a carbon atom broken down into 12 pieces. Okay, because the carbon atomic mass is 12, so it broken down into 12 pieces. So one piece of 12th carbon, so that's why 1 by 12th. One piece of 12th carbon they will compare with the mass of whatever the item you will bring. Okay, then relative to this 1 by 12th part of carbon atom, we will compare the mass of any element, and then we'll get to know how much this is heavier as compared to 1 by 12th of the part of one atom of carbon. Okay, this is a relative mass, or you can say atomic mass or atomic weight. So what it indicates, how many times the mass of one atom of carbon is heavier in comparison to 1/12 of mass of carbon atom. Why 12? Because we have broken down the carbon into 12 part. From that 12 part we will take a 1 part. So 1 by 12th part of 1 by 12th part of this mass of one atom of carbon, it will get compared with whatever the atom you are bringing, so that mass. Okay, yes, so this is the relative atomic mass. If you have understand, then just please reply in the comment box that you have understand. Okay, so or otherwise you will like it, so I will get to know that yes, you have understand. Okay, so what is the formula? Formula is similar. Relative atomic mass. Relative atomic mass. Yes, what we are doing in relative atomic mass? Yes, first of all we will write the mass of one atom of an element. Mass of one atom. Mass of one atom of any element. Mass of, see here, mass of one atom of an element. Mass of one atom of an element we will compare with the which, yes, 1 by 12th part, because we have broken down the carbon into 12 pieces. From that 12 pieces we have selected the one part, so 1 by 12th part. 1 by 12th part, 12, see, 1 by 12th part of mass of 1 by 12th part of mass of one atom of carbon 12. One atom of carbon 12. Now see, this is this carbon 12, I have written this. Okay, like this, carbon 12. Okay, of carbon 12. Understand the relative atomic mass? Yes, sir. We took a mass of an element, and this mass of an element will compare with what? 1 part of 12th. So 1 by 12th part of mass of one atom of carbon 12. Carbon 12, because the atomic mass of carbon, whose atomic mass of carbon is 12, we will take that carbon only. One more carbon is there whose atomic mass is 14. We are not considering that. Okay, we will consider only the atomic mass, means the carbon whose atomic mass is 12. Okay. So this is the formula of relative atomic mass. What is the formula of relative atomic mass? Mass of one atom of carbon. Okay, mass of one atom of carbon we will compare with what? Divided by, we are comparing with 1 by 12th part of mass of one atom of carbon. Okay. So this is a comparison. See, in the standard unit and all, they will say that, okay, we will compare this. If you want to compare with, means if you want to find the mass of any atom, we will compare with this. What is this? Because in market they will say na 2 kg, they have a 2 kg of weight. For 5 kg they will put a 5 kg of weight. Then they will compare the onion or apple weight, right? So like that only the scientist says that, okay, if you want to find the atomic mass of an element, any atomic mass, so what we are going to do, we are going to compare with this, relative to this. What is this? This is 1 part of 12th, right? 1 part of 12th. So 1 by 12th part of mass of one carbon atom, mass of one carbon atom. From this, we will not take all the 12th part of carbon atom. We will just take 1 part of the 12th carbon atom. We will take just one part of 12 carbon atom, that mass, okay, of one atom of carbon, that we will compare with the whatever the element you are bringing, that atomic mass. Okay, fine. So relative atomic mass, because this is important, they will ask in the examination. So relative atomic mass means mass of one atom of element divided by 1 by 12th part of mass of one atom of carbon. Now see here, now this thing, see 1 by 12th part of mass of one atom of carbon. So see what will happen, 1 by 12th part of means what? Of means multiply. So 1 by 12th part of mass of one atom of carbon 12. So mass of one atom of carbon 12 means what we know. Yes, as I have said you, we will take this carbon whose atomic mass is 12. We will not take the carbon whose atomic mass is 14. We will take the carbon whose atomic mass is 12. So mass of one atom of carbon is how much? 12. So 12 divided by 12 is 1. And we will just write unit. Later we will talk about the units. Okay, we just write the unit. So what does this mean? This means that this 1 by 12th part of mass of one atom of carbon 12, it is nothing but 1 unit. It is nothing but 1 unit. So guys, suppose if you are bringing the mass of one atom of carbon. So suppose the mass of one atom of a carbon you measured, it came 12. Okay, divided by this mass of one atom of an element means mass of one atom of, will bring the carbon. So its mass is 12. So you like, how we'll get to know its mass is 12? Because we will measure in the laboratory. We will measure where? We will measure in the lab. Okay, and the machine used for measuring mass is mass spectrometer. We will use the machine mass spectrometer, and from there we will find the mass of one atom, means whatever atom you will take and go. Suppose we take and go the carbon atom. So we will bring out that machine, that called is mass spectrometer. Machine name is mass spectrometer. In that mass spectrometer machine we will keep the carbon atom. So its weight is like 12. Okay, so mass of one carbon atom is 12 divided by this. We have to compare with this, right? Because this is a relative by which we are comparing. So this value is what? This value 1 by 12th part of mass of one atom of carbon. This value is nothing but 1 unit. This value is nothing but 1 unit. So divided by 1 unit. So it is 12 unit. Okay. So this is the method how we will find. Okay. How we are finding the atomic mass. So don't write this one. Okay. What you will do is first write down the atomic mass, atomic weight, this topic. Then write down this one and the formula and just write down this. Excuse me. Write down this for your understanding. Okay, like 1 by 12 means 1 by 12th part of means multiply. So mass of one atom of carbon whose mass is 12. So into 12 will get cancelled. It is 1 unit. Means what? We are comparing with 1 unit. This 1 unit we are comparing the other atomic mass. Suppose if you bring a carbon and we compare, the carbon is 12 times heavier with this unit. Carbon is 12 times heavier with this unit. So what is the unit? 1 unit, right? This side is what? This side is relative. So relative is what? This is the 1 by 12th part of mass of one atom of carbon, 12. So this is a relative. So what is the weight of this relative? This relative weight is 1 unit. What is the weight of this relative? Relative weight is 1 unit. What is the relative weight? Yeah, relative weight is 1 unit. So if you will bring a carbon and you will see that, oh, carbon is 12 times heavier than this 1 unit. Carbon is 12 times heavier than this 1 unit. So what is that? This is the 1 unit. Anything you will do, multiply, divide, anything you will do with 1 unit is the same number only. So carbon is how much? 12 times heavier than this 1 unit. So what is the atomic mass of carbon? 12. Okay, if suppose you will bring oxygen and we saw that, oh, oxygen is 16 times heavier than this relative unit. So what is the relative? Relative is this 1 by 12th part of that mass of one atom of carbon. So its value is nothing but 1 unit. So we'll see that, oh, oxygen atom is 16 times heavier than this 1 unit, which is the relative for comparison of this. So we will say that, oh, atomic mass of oxygen is 16 because this atomic mass of oxygen is 16 times heavier than this relative mass. Relative mass means 1 unit. Understand? Yes. So what we have to compare? We have to compare relative to this. We have to compare relative to this 1 by 12th part of the mass of one atom of carbon, 12. We have to compare with the relative to this. So what is the weight of this, by which what we are comparing, like 1 by 12th part of the mass of one atom of carbon atom, we are comparing with this. So what is the unit of this? This whole unit, after finding, we get to know this whole unit is nothing but 1 only. This whole unit is nothing but 1 only. So this, the value of this all is nothing but a 1 unit. From here we have to compare how much other atoms are heavier. So how much the other atoms are heavier, that is its atomic mass. Like as I have said, your atom, so oxygen atom is how much? Oxygen atom is 16 times heavier than this relative mass, 1 unit. So 16 times heavier means 16 unit. That's it. Suppose 20 times heavier, 20 units, because this is what? This is nothing but a 1 unit. If you will multiply with 1, if you will multiply with 1 or if you divide with 1, whatever, the same unit you will get. That's it. So guys, till now what we have studied, atomic mass and weight. We get to know in chemistry, mass and weight both are same. So whatever we are finding the atomic mass or whatever we are finding the atomic weight, it is based upon relative atomic mass, related to something we are finding. Okay, like as I have given you the example, when you will go for a shop, 2 kg of onion, they will give related to that 2 kg of weight. 5 kg of onion, they will put a 5 kg of weight, then they will give the onion related to this weight. Okay, because every time we'll watch this weight, this is the related weight. So that will be relative. So here also the atomic mass, if you have to find the atomic mass of any atom, what we are going to do, we have to compare the 1 by 12th part of mass of one atom of this carbon 12. So this is the relative, this is the relative, not your this is the relative. Okay, so because in life also they will compare with relative, right? Sharma ji ka beta ko dekho. So in the life also they will compare with the relative. So here also atoms also they will compare with the relative, the weight. Okay, so in the life also they will compare with the relative. So here also in the chemistry also they will compare with the relative. Okay, so what is the relative? Relative is 1 by 12th part of the mass of one atom of carbon 12. So what is the value of this much what I have said? 1 by 12th part of the mass of one atom of carbon 12. Its value is nothing but 1 unit, because when I have did here 1 by 12th part of, so 1 by 12th into mass of one atom of carbon whose atomic mass is 12. So 12 will get cancelled, we'll get a 1 unit, so 1. Okay, that's how we got the 1 by 12th part. We bring the carbon, we have divided into 12 parts, so we'll take the 1 of the 12 parts. Okay, so relative mass formula is this. So I hope everyone understand till here. This is a very important topic, you have to understand. Okay, now we will come the unit for this. What is the unit for this? Because unit is very important. See, the unit we will say is atomic mass unit. What the unit we will say? Unit we will say is 1. Because what we have find? Yes, we are finding the atomic mass. We are finding the atomic mass relative to this 1 unit. We are finding the atomic mass. So that's why it is atomic mass unit. So that's why it is 1 atom mass. So 1 atom mass, because what is that? That is the atom of 1, right? Oxygen atom. So that is the 1 oxygen atom. So that's why 1 atomic mass unit. Okay, 1 atomic mass unit. 1 atomic mass unit is what? 1 AMU. AMU is atomic mass unit, is equals to 1 by 12th into weight of 1 carbon 12 atom. See, every time why I will write the carbon 12, because you have to understand that which carbon we have taken whose atomic mass is 12, because I have said another carbon is there, C14, whose atomic mass is 14. We will not consider that. We are considering the atom whose atomic mass is 12, because see the atomic mass of, we have taken 1 carbon atom, okay, of atomic mass 12. Okay, so suppose as an example, if you have to find the atomic, I can write mass, weight, whatever, both are same. If you have to find the atomic weight of oxygen, atom. So atomic weight of oxygen atom, how we'll find? We'll write the weight of, we'll find the weight of 1 oxygen atom. We'll find the weight of 1 oxygen atom divided by this 1 by 12th into weight of 1 carbon 12 atom. See guys, this all the things you have to write. Okay, now what we are finding? We are finding the 1 atomic mass unit. So for 1 atomic mass, because whenever we are finding for 1 atom. If I will say the oxygen, atomic mass of oxygen is 16, means what? 1 oxygen atom is equals to 16. Okay, 1 oxygen atom, its atomic mass is 16. One atom. Okay, so that's why 1 atomic means atom mass unit. We have to find the atomic mass unit. So 1 atom mass unit. So 1 atomic mass unit is what? We know 1 by 12th into weight of 1 carbon 12 atom. So suppose we'll take the atomic weight of oxygen. Okay, so atomic weight of oxygen is what? We will take a weight of 1 oxygen atom. So weight of 1 oxygen atom is how much? Weight of 1 oxygen atom is 16, divided by 1 by 12th into weight of 1 carbon 12 atom. So this is weight of 1 carbon 12 atom is how much? Atomic mass is 12. So 12 will get cancelled, it is 1. So it is a 16 what AMU. We will write here AMU. AMU means what? This atom, atomic mass unit. Okay, so atomic weight of oxygen atom is 16. Now you will ask her how we will get to know it is 16. How we will get to know? Because I have said you they will measured in the machine. See this mass, whatever the weight, this weight they will measured in the laboratory. So machine used. So we will use the machine used is mass spectrometer. Machine used is what? Mass spectrometer. This is a machine. We will use the mass spectrometer machine. By using that machine we will get to know that this weight of one oxygen atom. Okay, because everything is a process. Like, so it's not like you Dalton wake up in the morning, what is this? Oxygen. Oh, today oxygen is looking good. Okay, atomic mass 16. I enjoy. They will say that, oh, nitrogen. Nitrogen is not looking good. Atomic mass 14. They will say hydrogen. Hydrogen. Very bad. Atomic mass 1. They have not did like that, right? So they have measured it experimentally, and where they have measured, they will measure in the lab. It's not they will put in the road, right? TikTokers they will do in the roads everything. So it's not like that. So they will measure in the lab. So machine used in for measuring is mass spectrometer. Now we will ask why we will take carbon only as standard. Why not the oxygen as standard? Why not the nitrogen as standard? Why we will take the carbon as standard? So for this also we will write down. We'll write a note, because see these things they will not ask in the examination, but you should have to know the concept. Why we have choose the carbon only? Why carbon? Why mithai wala? Why? Why we will take the carbon only? So we will write why we take carbon as standard. Why we take carbon as standard? Because other elements, atoms, we're finding the atoms. Other atoms gives fractional weight. Okay, why we consider as standard? Why we take carbon as standard? Because other atoms give fractional weight, but carbon atoms gives whole number, which makes it easy to remember. Because see, if you see what we are taking the 1/12 part. So 1/12 into, if suppose we will take the oxygen is 16. Oxygen is what? 16. So 1/12 into 16, we will get the answer in 1 point something. Okay, so 1.3 something you will get like that. So it is in a point, we will not consider. But when we will consider the carbon atom, so what is this? 1/12. So that's why guys, it is the 1/12 into carbon of mass 12. So 12 will get cancelled, it will become 1 unit. So that's why they said when we take carbon as standard. Why we take carbon as standard? Because other elements give fractional weight. The weight is in fraction, so it will be difficult for doing the calculation, and it is difficult for remembering also. But carbon atom gives whole number. Why it is give whole number? Because the denominator will come 1 unit. So 1, no value of 1, right? Yes. But carbon atom gives whole number, which makes it easy to remember or easy to do calculation and all. Okay. So copy it down. Okay. Done. Now next thing. Now here only I will write a little bit of. Now next thing guys, we will see the AMU, because still we have not find the mass. Sorry, still we have not find the what unit. Just we get to know unit is AMU. AMU. So now we will see the relation between. Okay, till now whatever we are finding will keep AMU. Like suppose the mass of oxygen 16 AMU means 16 atomic mass unit, 16 AMU, or you can say 16 U. U means unified mass, because this is unified. Okay, they have already make it proper. So you can say till now you can say the mass of oxygen atom is what? Mass of one oxygen atom. Mass of one oxygen atom is 16 AMU or 16 unit or 16 U unified mass 16 U. Okay. So now we are going to learn about what? Now we'll see the relation between AMU atomic mass unit and grams, because somewhere you will see they will write the 16 gram. We will say sir 16 grams, sir grams, sir gram. Now here we will get to know. Okay, here we will get to know each and everything. Okay, so first of all we'll find the relationship between AMU and not the relationship. Relation between AMU and grams. Relation between AMU and grams. Now see, this we know, because see till now we don't know. We are just saying the AMU or unified mass. But when we will use, what we are using, atomic mass of oxygen is 16 gram, atomic mass of carbon is 12 gram, nitrogen is 14 gram, hydrogen is 1 gram. So we are saying like that, correct? So first of all we have to know how much it is. Okay, so relation between AMU and gram. So what we know? We know that 1 AMU is what? 1 AMU is, yes, 1 by 12 into weight of 1 carbon 12 atom. Okay, so 1 AMU equals 1 by 12 into, guys remember this thing, they have already measured this as a standard. What? In the international standard units they have already measured this, like weight of 1 carbon 12 atom, weight of 1 carbon 12 atom is 1.99 into 10 to power of minus 23 gram. Okay, see this, 1.99 into 10 to power of minus 23 gram. Okay, 10 to power of minus 23 gram. This already they have measured in a standard, international standard unit. 1 AMU is what? 1 by 12 into weight of 1 carbon 12 atom. So weight of 1 carbon 12 atom is how much? 1.99 into 10 to power of minus 23 gram. So now 1 atomic mass unit we can make like this, 19.9 divided by 12 into 10 to power of minus 24 grams. So see, when once we will divide it, we will get 1 AMU is what? 1 AMU value is 1.66 into 10 to power of, when you will divide this, 1.66 into 10 to power of minus 24 grams. See, what we get to know? We get to know 1 AMU. What is the value of 1 AMU? 1 AMU is 1.66 into 10 to power of minus 24 gram. How we get to know? We got from here. Okay, by doing this all calculation. So remember the thing, weight of one carbon 12 atom is how much? 1.99 into 10 to power of minus 23 gram, because we have to write AMU in grams, right? Because relationship between AMU and gram, so we have to convert this into gram. So this weight of one carbon 12 atom is 1.9 into 10 to power of minus 23 gram. So after doing this all calculation, we got 1 AMU. What is the value of 1 AMU? 1.66 into 10 to power of minus 24 grams. Okay. Now in this only continuation, guys, suppose if we'll take an oxygen atom. So 1 AMU, 1 atomic mass unit of oxygen, how much? How much 1 atomic mass unit of oxygen? Yes, 16. So it is what? 16 AMU of oxygen. 16 AMU of oxygen is, guys, what? 1 atom of oxygen. Yes, sir. 1 atom of oxygen. Okay. 16 AMU of oxygen means what? 16 AMU means 16 unit. 16 unit of oxygen is what? 1 atom of oxygen, right? So 1 atom of oxygen is how much? 16 unit. Okay. So 16 AMU of oxygen is almost 1 unit. Sorry, one atom. 16 AMU of oxygen is what? 1 atom. So guys, 16 into, because you have to find in gram, 16 into AMU of AMU is what? 1 AMU is this much. 1.66 into 10 to power of minus 24 oxygen, which is nothing but 1 atom of oxygen. Okay, because we know oxygen atomic mass is what? 16. So 16 AMU of oxygen is what? 1 atom of oxygen, because 1 atom of oxygen will consist of 16 unit. So one oxygen atom is 16 AMU of oxygen. Okay, so we know 1 AMU is this much of gram. So 16 AMU means 16 into this much of oxygen. Okay, so what is this? 16 AMU means this will come under 16 gram. Okay, I'll change it. So from here, guys, what will happen? 16 into 1.66 into 10 to the power of minus 24 oxygen, that is nothing but 1 atom of oxygen. So what we have to do? We have to find for, because see, this came in gram, this now it is in gram. Why it is in gram? Because we have substituted in place of AMU, we have substituted this value which is in gram. So we have substituted this value which is in gram. Okay, so now we see that 1 gram of oxygen, 1 gram of oxygen will contain how much? 1 gram of oxygen will contain 1 divided by this much, correct? Because this will come this side, this will come this side. So 1 gram of oxygen will be 1 divided by how much? Yes, 1 divided by 16 into 1.66 into 10 to power of minus 24. Correct? Yes. So how much gram of oxygen is there? Yes, 16 gram of oxygen. So 16 gram of oxygen means 16 divided by 16 into 1.66 into 10 to the power of minus 24. Okay, so what will happen? 16 will get cancel. We will get 1 divided by 1.66 into 10 to the power of minus 24. 1.66 into 10 to the power of minus 24. So what we will do? This will go up. So it will become 10 to the power of 24 divided by 1.66. So we will separate it. We will make a 10 for this 1.66, and the remaining is 10 to power of 23 here. So once you will divide it, you will get how much? 6.023 into 10 to power of 23 oxygen atom. See what we get to know. Yes, 16 gram oxygen. 16 gram of oxygen, how much it will consist? It consists of 6.023 into 10 to power of 23 oxygen atom. Guys, see how much it is small. Okay, how much it is small. So that's why we will consider it directly only 16 AMU, or we'll say 16 unit, or we'll say 16 gram, because when we will compare, it will be a very small unit. And what is this 6.023 into 10 to the power of 23? Avogadro number. Okay, so guys, see 16 gram of oxygen. So 16 gram of oxygen. So this is what? This is a one molecule, 1 mole. 1 mole is how much? 1 mole is 6.023 into 10 to power of 23. This is the mole concept. 1 mole, 6.023 into 10 to power of 23. When you will take the 1 mole of anything, 1 mole of oxygen, 1 mole of hydrogen, 1 mole of sodium, 1 mole of potassium, 1 mole of iron, 1 mole of cobalt, 1 mole of argon, anything of 1 mole, it is 6.023 into 10 to power of 23. This is nothing but Avogadro number. Avogadro's number, and we know this number is nothing but a constant number. So how we got this Avogadro number? Like this. So see, till now we get to know atomic mass, atomic weight, relative atomic mass, all are same. Whatever we want to find the atomic mass of any atom, we will compare with that the relative mass. What is the relative mass? This is the relative mass, 1/12th part of the mass of one atom of carbon 12. So this value, relative mass value, is nothing but 1 unit. How we got to know? We got to know from here, 1 unit. So means if you want to compare the relative atomic mass, that is equals to nothing but mass of one atom, any one atom, right? Mass of one atom of an element divided by this relative mass. Relative mass value is what? 1. So whatever you will bring the mass of one atom, that will only become the atomic mass unit. Okay, and we have to see the unit. Unit is atomic mass unit, AMU, correct? So 1 AMU is how much? This much of carbon. So atomic mass, suppose if you want if you have to find the atomic weight of oxygen, it is weight of one oxygen atom divided by 1/12 into weight of one carbon 12 atom. So weight of one oxygen atom is 16 divided by, this is 1/12 into, so we know relative mass unit is 1 only. So it will become 16 AMU. AMU, why we are writing? Because it is the atomic mass unit. So 16 atomic mass unit, because we don't know the units. 16 AMU, 16 atomic mass unit. So how we get to know this weight of one oxygen atom? This weight of one oxygen atom is 16, because in the laboratory they will compare with the machine. That machine is mass spectrometer. Okay, so now we have to see, as we are writing 16 AMU, but you will say that okay sir, it is 16 AMU, done. But so many places what I will see is, I will see they will say that 16 gram, right? Atomic mass of oxygen, they will say 16 AMU. Okay, you are saying 16 atomic mass unit, or someone will say 16 unit, or someone will say 16 U means unified mass, or someone will say 16 gram. How sir this all is changing? Atomic mass unit, unified mass, okay, both are same. Atomic mass unit or unified mass is okay. Atomic mass unit and then gram. Sometimes you will say, means we can say 16 U also, means unified mass, or 16 AMU, or sometimes we can say 16 gram also. How? Okay, how it is possible? Because AMU is atomic mass unit and gram both are different. So we will say that no. Come, we will see how much atomic mass unit and gram are different to each other. Why? Because sometimes they will say, we will say the one atomic mass 1 atomic mass of oxygen is 16 U, or sometimes they will say 1 atomic mass of oxygen is 16 gram. Why it is same only? So we will say that come we will see the relation between AMU and gram, how much the AMU and gram are differ. How much the AMU and gram will differ. So what we took this 1 AMU is how much? We know that 1/12 of weight of 1 carbon 12 atom. So 1 AMU is 1/12 into this already, that is in international standard unit. You have to remember it is like, we know the gravitation is what, 9.8, or we will use 10 meter per second square, right? This is fixed, we cannot able to change it, right? In the earth it is fixed. So like that only, weight of 1 carbon 12 atom is already fixed by international standard unit, and its value is 1.99 into 10 to power of minus 23, because it will convert it into gram. Because why? We are comparing the AMU and gram, means how much the 1 AMU is how much gram. Okay, because we have to know that why sometimes we will write the atomic mass is 16 U, means 16 AMU, or sometimes we will write the 1 atomic mass of oxygen is 16 gram. Why? So we will see 1 atomic mass is this much. So once we will do all the calculation, we will get 1 atomic mass unit is nothing but 1.66 into 10 to power of minus 24 gram. You can see the value, how much it is small. So that's why AMU and gram both are similar, because 10 to power of minus 24. So it is a really very small. If you will keep in your hand, you don't feel also that this 1.66 into 10 to the power minus 24 gram is in my hand. Okay, so they will say that, oh, that's because of this 1 AMU value. If you compare with the gram, this value is very small. So that's why we will take the AMU in the same gram only. We will take the 16 U, or we will take the 16 gram. Okay, so now we have compared with the example. We have compared with the example of oxygen. Okay, we have compared with the example of oxygen. So see, 16 AMU, because oxygen is how much? Yes, 1 atomic mass of oxygen consists of 16 U. So 16 AMU of oxygen is what? 1 atom, correct? We know this. 1 atomic mass is 16 U. So 16 AMU of oxygen is how much? 1 atom of oxygen. 16 AMU of oxygen is how much? 1 atom, right? 1 atom of oxygen consists of 16 AMU of oxygen. So 16 AMU means we have to convert into gram. So 16 into 1.6 is this much gram oxygen. We have converted AMU into gram. So this means 1 atom of oxygen. See, 1 atom of oxygen will consist of 16 AMU. Once we will convert, then the 1 atom of oxygen will consist of 16 into 1.6 into 10 to the power minus 24 gram, means still 16 gram only. So you can see here, one oxygen of atom, it will consist of 16 AMU, or 1 oxygen of atom, it will consist the same 16 gram, because this is very small. So what will happen? Now we have to find the 1 gram of oxygen. 1 gram of oxygen is 1 divided by this all. This all will go this side, so it will go in divide. So 1 divided by this much, right? So we have to find a 16 gram, correct? We don't want this 16 into 1 this much. We have to find for 16 gram. So 16 gram means we'll multiply. So after that cancellation and all, we got this 16 gram of oxygen will have this much, 6.023 10 to the power of 23 oxygen atom. So see how much it is small. Okay, because the values of the 16 U and 16 gram is not much differ. It will be like 0.0 something. Okay, like 6.023 10 to the power of 23 means 0.0023, then 6023. So that's why we can see how much it is small. Okay, how much it is small. So that's why we will compare both as a similar only. Just we will change the unit. Okay, the values, the magnitude will remain same, just we will change the unit. So what we got the 16 gram of oxygen is how much? 6.023 10 to the power of 23 oxygen atoms. So this value what we got, This value is for all, even for oxygen, nitrogen, sodium, potassium, magnesium, argon, for all it is. Okay, so this value is called as Avogadro's number. This value is what? This value is called as Avogadro's number. Means what is this? This is the 1 mole molecule, right? 1 mole. Okay, so 1 mole of anything, 1 mole of oxygen, okay, 1 mole of nitrogen, 1 mole of anything. If they will say 1 mole of anything, 1 mole means 6.023 into 10 to the power of 23. 1 mole of anything. So this how we got the mole values. So we see that if you'll take the 16 U or 16 gram, both are similar. Why? Because the difference is, you can see the difference, 10 to the power of 23. The difference is this much small. So that's why it is not differ. The magnitude will remain same, just the unit will keeps on changing according to like what we have to find. The units will keeps on changing, but the magnitude will remain same. Okay, like example, if I will tell you 1 mole of oxygen atom, now we'll see 1 mole of oxygen atom is how much? Yes, 1 mole of oxygen atom is 6.023 into 10 to the power of 23 Avogadro number. And 1 mole of oxygen atom, how much? Yes, 16 grams. Right, both are same. Correct. 1 mole is how much? 1 mole, we know that here, see, 1 mole is 16 gram. Correct. The 16 gram will be nothing but 16 AMU, right? As I have said you here, AMU, gram, both are same. Okay, AMU, gram, both are same. So what is this? 1 mole of oxygen atom is this much Avogadro number, which is a 16 gram. So finally what we get to know? We get to know 16 AMU of oxygen atom. 16 AMU of oxygen atom is nothing but weight of one oxygen atom. So 16 gram is also weight of one oxygen atom. Correct? Yes. But the unit is changed. That is 16 AMU. That is 16 gram. But weight of one oxygen atom is how much? 16 only. Magnitude will remain same. Just the unit will keep on changing. That's it. Weight of one oxygen atom 16 AMU, 16 gram, both. Just what the thing will change? The thing will change is only the unit will change, magnitude will remain same. Okay, means guys, this all the things you have to write in the back page. Also what I have written, you have to write all those things. Okay, this all the things, this is the relation between AMU and gram. So this is the relationship of AMU and gram. This, okay, 1 AMU is this much gram. Again, this is the example we will start calculating. So finally we will get it here. 1 mole of value is this much. Okay, so 1 mole means of anything. If you talk about the 1 mole of anything, its value should be this much. Okay, and then this value is what? It's gram, weight. So weight of one oxygen atom is also 16 gram, and we can say the 16 AMU. Magnitude remains same, just what the changing is the units. Okay, now next thing is when atomic mass. See, these things they will not ask in the examination, just for your understanding, like why we will write the 16U or we will write the 16 AMU or we will write the 16 gram. Why it's all are same? Because of this reason. The values of the bit difference between the AMU and gram is 6.023. Sorry, the value of AMU and gram is 1.66. This value, see, yeah, a 1.66 in 10 to the power minus 24 gram, which is very smaller. So we'll compare the AMU and gram similar. Okay, so see, when atomic mass of an element, is expressed when atomic mass of an element is expressed in grams. Okay, when atomic mass of an element is expressed in gram, it is called gram atomic mass. See, just the unit will change in which you are expressing, the unit will change according to that. Okay, see, if atomic mass of an element is expressed in gram, so it is a gram atomic mass. So what is a gram atomic mass? Means by the name you will understand, atomic mass in gram. So suppose as the example, if I will take the atomic mass of oxygen, atomic mass of oxygen is 16. Okay, if you are writing AMU, it will become 16 AMU. If you are writing, if you want at gram atomic mass of oxygen, means atomic mass in gram. If you want gram atomic mass, means atomic mass in gram. So atomic mass in gram, what? It will become 16 gram. See, atomic mass is 16, it is in gram. Atomic mass in gram, atomic mass means atomic mass which is in gram. So 16 gram means atomic mass is 16 and we are expressed in gram. So 16 gram. Okay. Now next we have to write the very important thing. Next, another note. See, the molar mass. Most of the student will get confused here only. The molar mass, molecular mass. Okay, so we will write. So this is easy. I hope everyone understand what is gram atomic mass. So whatever the mass of one atom, if you will express in gram, that is a gram atomic mass. Like suppose if you take about carbon, let's take carbon only. What is the atomic mass of carbon? Atomic mass of carbon is 12U or 12 AMU. If we want to write the gram atomic mass of carbon, gram atomic mass means atomic mass is expressed in gram. Gram atomic mass of carbon, it will become 12 gram. If I will say atomic mass of carbon, 12. Now expressed, if you want to express in AMU, so 12 AMU. If you want to express in U, 12 U. If you want to express in gram, that is gram atomic mass, 12 gram. That's it. Molar mass and molecular mass. Okay, the student have a doubt in this. Molar mass and molecular mass. Okay, molar mass and molecular mass have same molar mass. Molar mass of carbon is 12, molecular mass of carbon is 12. So they said the molar mass and molecular mass have same magnitude. Molar mass and molecular mass have same magnitude but different units. Okay, molar mass and molecular mass have same magnitude but different unit. If I will tell you the molar mass of anything, okay, so remember the thing, just I will write it here. So molar mass, they said the molar mass and molecular mass have same magnitude but different units. So what is the units? Okay, see, molar mass unit is gram per mole. Molar mass unit is gram per mole. Molecular mass is AMU. Okay, AMU. That's it. Okay, molar mass and molecular, see, everyone have the same magnitude. What I said, everyone have the same magnitude but different in units. That's it. Atomic mass of carbon 12. Atomic mass of carbon is 12, or atomic mass of oxygen is 16. We know that atomic mass of oxygen is 16. That's it. Magnitude remains same. If you want to express in AMU, 16 AMU. If you want to express in U, 16 U. If you want to express in gram, 16 gram. If you want to express in molar mass, 16 gram per mole. Whatever, it will remain same. The magnitude will remain same, just the unit will change. Okay, so that's why when I will give you, after this I will give you the atomic mass, I will not write the unit. We will not write the unit, we will write just the values. because unit will differ. If you are finding the gram atomic mass, it will become gram. If you are finding the molar mass, it will go in gram per mole. If you are finding the molecular mass, it will be U. Okay, so that's why we are writing just the magnitude, because magnitude will remain same, it will never change, but what we are finding, according to that the unit will change. Okay, because sometimes the student will write for molar mass 16 gram, 16 gram for molecular mass, also for molar mass also 16 gram, gram atomic mass also 16 gram. No, the magnitude is same, I am accepting magnitude is 16 only, but for gram atomic mass 16 gram, but for molar mass gram per mole, molecular mass AMU, unit will keep on changing. Okay, understand this. Next is, okay, this molecular mass is what, AMU, but if molecular mass, see all these things you have to write, whatever I am writing you have to write all these things, because this is the notes also. Molecular mass is measured, guys, each and everything you have to write whatever I am writing. Molecular mass is measured, if suppose molecular mass is measured in gram, if suppose molecular mass is measured in gram, what will happen? Yes, is called gram molecular mass, obviously. See, the value will remain same, 16 only. Okay, if suppose we are finding the molecular mass of anything like water is 18. If you are finding the molecular mass of water, it is 18 AMU. If you are finding the gram molecular mass of water, it will become 18 gram, because expressed in gram or measured in gram. What is the magnitude? If you are finding the molar mass of water, 18 gram per mole. What is this value? Same, 18, but the units are changing. That's it. I will tell you how to find. Okay, the very important thing. Most of the student will get confused here. Now guys, we will write the element. Now we'll write the element name, its atomic number, and then its atomic mass. See, I will tell only atomic mass, because as we have seen here, molecular mass is AMU, but if you will express the molecular mass in gram, it will become gram molecular mass. So the units will keep on changing, but the values will never change. So that's why we will write the values without units. Okay, so we'll write till 20. Atomic number 1. Atomic number 1 is hydrogen. You have to remember till 20. Hydrogen. Atomic number 1 is hydrogen. Atomic number 2 is helium. Lithium is atomic number 3. Hydrogen, helium, lithium, beryllium. Okay, beryllium. Beryllium is atomic number 4. Boron. Boron is atomic number 5. Then carbon. This is a standard. Okay, carbon atomic number is 6. This, what I will write, the atomic mass for all. The atomic mass is standard. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. Nitrogen is 7. Then oxygen. Oxygen is 8. Carbon, nitrogen, oxygen, fluorine. Fluorine is 9. Then next is noble gas, neon. Neon is 10. Then write till here, then the next page we will write. Okay, so hydrogen atomic mass is 1. Helium atomic mass is 4. Lithium atomic mass is 7. Beryllium atomic mass is 9. Boron atomic mass is 11. Carbon atomic mass is 12. Nitrogen atomic mass is 14. Oxygen atomic mass is 16. Fluorine atomic mass is 19. Then neon atomic mass is 20. See, all the atomic mass is a whole number. We are not getting in fraction and all. So that's why we have used the carbon atom. So till here it's done. Now we'll write the 11th number. atomic number 11, hydrogen, neon. After that it will be a sodium 12, 13, sodium, magnesium, aluminium, sodium, magnesium, aluminium. Then 14th number is silicon. Then 15 is phosphorus. 16, 17, 18, 19, 20. Okay, phosphorus. Then 16 is sulfur, chlorine. 18 is argon. 19 is potassium. 20 is calcium. Okay, now we'll write the atomic mass. Atomic mass of sodium is 23. Atomic mass of magnesium is 24. Aluminium is 27. Then silicon is 28. Okay, potassium is 31. Sulfur is 32. Then chlorine is 35.5. Only this one is exceptional. Argon is 40. Potassium is 39. And then calcium is 40. Okay, so these all the things you have to pause and you have to copy it down. Now guys, we are going to find what? Yes, we are going to find the molecular mass. See why I'm doing in one video only, because these all are related to each other. Okay, molecular mass or relative molecular mass. Guys, see molecular mass, or you can say molecular weight. Okay, molecular mass, molecular weight, or formula mass, or relative molecular mass. Okay, all is same, but all are expressed in u or mu. Okay, now when we will express in gram, when it is written gram, like gram molecular mass, so the same thing it will expressed in gram. Gram molecular weight. Okay, gram formula mass. Okay, with gram relative molecular mass. So if it is like word gram is there, okay, if the word gram is there, then only we are going to express in gram. Remaining all the process will remain same. Will do. First number. Okay, molecular mass or molecular weight or formula mass or relative molecular mass, all units is u, not u. Okay, now first we'll take for H2O. Okay, so H2O, so hydrogen. First of all we have to see this atom, hydrogen. What is the atomic mass? Because we are finding the mass, weight or mass, same, mass. So if we are finding the mass, what we have to see? Yes, we have to see the mass for finding the mass. If you are finding the mass, you have to see the mass. So molecular mass means, first of all we will find the hydrogen mass, then we will find the oxygen mass, we will combine, that is whole molecule mass. That's it. Molecular means mass is what? We will first compare, means first we will find the hydrogen mass. Next item is what? Oxygen. We will find the oxygen mass. We will add, it will become the molecular mass. Correct? So hydrogen atomic mass is how much? 1. And how many hydrogen are there? 2. That is very important, right? H2O means the 2 hydrogen, 1 oxygen. Means atomic mass of hydrogen is 1. Then again plus 1 plus oxygen is 60. Like this. Okay. So in place of writing like this separate, we can directly multiply here 2. So it will become easy for the calculation. Okay, so first is what? Hydrogen. Hydrogen means atomic mass of hydrogen is 1. Very good, 1. And how many hydrogen is there? 2. So 1 into 2, whatever you will get, we have to add with oxygen, because hydrogen is done. Now oxygen, atomic mass of oxygen is 16. And how much oxygen is there? 1 only, 16. So 1 into 2 is 2 plus 16, that is 18 U. Okay guys, here molecular mass, weight, formula mass, relative molecular mass, they have not mentioned gram. If suppose they will say the find the gram molecular mass, mean the process will remain same. In place of 18 U, you have to write the 18 gram. 18 U, this is what? This is the molecular mass, molecular weight, formula mass, relative molecular mass. This is 18 U. But if you have to find the gram, like here what we have written, if molecular mass is measured in gram, it will become gram molecular mass. If you have to find the gram molecular mass, the process will remain same, magnitude will also remain same, just the unit will change into gram, because we have to find the gram molecular mass. That's it. Now second number. Remember the thing, the student will get confused here. Okay, they will write the different unit. Because of that, they will lose the marks also. Until and unless they will not mention the gram, we are not writing the gram as a unit. Molecular mass, molecular weight, formula mass, relative molecular mass, whatever, U only. Unified mass, U. If they will mention the gram, like gram atomic mass, word gram came, then only it will become 18 gram. Otherwise, it is not gram. Now we'll do for CO2. CO2 means carbon. Carbon is, what is the atomic mass of carbon? Yes, 12. And how many carbon are there? 1. So done for the carbon. Then we'll go for oxygen. Means we have to add, right? We have to add for all the atoms. So atomic mass of oxygen is how much? 16. And how many oxygen are there? 2. So 16 into 2. So 12 plus 16 to the 32. 32 plus 12, 44. We have to find the molecular mass. So U. If you have to find the gram at molecular mass, 44 gram. Next, third number. Okay, HCl, chlorine. Yeah, HCl guys is your homework. You have to find and you have to reply in the comment box. Then glucose, C6H12O6. Ore baba, very simple. First is carbon. So we'll see the atomic mass of carbon. Atomic mass of carbon is 12. So 12 into how many carbons are there? 6 carbon. So atomic mass of 1 carbon is 12. So here it is a 6 carbon. So multiply with 6. Done for the carbon. Then for hydrogen. So we have to add for every atom. We have to add all. Then only the molecular mass. Now hydrogen. Atomic mass of hydrogen is 1. And how many hydrogens are there? 12 hydrogen. So into 12 plus for oxygen. Atomic mass of oxygen is how much? Yes, 16. Into number of oxygen is 6. Add 12 6 the 72 plus 12 1 the 12 plus 16 6 the 96 into 96 plus 12. It is 108. 108 plus 72, 180. 180 U, because it is a molecular mass. If it was gram molecular mass, 180 gram. Okay. Then like that only guys, I will give you the homework. Okay. HCl was the one homework. Then NaOH is the other homework. Okay. Then next is CH4. Then 7th is C2H5OH. Okay, then okay, this much. Okay, so this is the end for the today's class. Very important class. Okay, I know this is a bit lengthy classes. It is, oh my god, 1.5 hour. Okay, it is 1.5 hour classes. Okay, so fine, because very important topic. This is a very important topic. Where the most of the student will get confused between the AMU and gram. See, these all topics are related. Okay, atomic mass, atomic weight, how we are finding it. Okay, then one AMU is how much gram. Okay, because sometimes as we have seen it here, right, we will write the 16 18 u also, we'll write the 18 gram also. The so many students we have a doubt, like why the 18 u only and why the 18 gram only, or why the 18 amu only and why the 18 gram only, how the both are same. So because of that we have shown it here. They are not same, they are not same, but the values as we'll compare is very small, so that's why we'll consider it as same only. After that we have find the one mole which is related to that. Then after that, how we will get to know it is a, when we will apply the g. Yes, when they were, when if anything is expressed in gram, like when the atomic mass, if normal atomic mass means u only, amu, okay, or u. If it is a gram atomic mass, if expressed in gram, gram atomic mass means 16 gram. So I have given here the very important thing, same magnitude but different units. Magnitude will remain same, unit will change, depends upon that. If the molar mass, gram per mole. Here now see, we are finding the molecular mass. Molecular mass means u, correct. But if the same thing they will say what, gram molecular mass, so same it will become 18. In place of 18 u we will write 18 gram. So the many students have a doubt upon this, so that's why this is a whole video, okay, for one concept which is related to, one concept which is related to each other. Okay, one concept which is related to each other. So I hope you understand. If you understand, hit a like button, so I will get to know that you have understand. Share with your friends, so that's why they will also get benefited. And the answer for this, comment in the comment box. Okay, don't write this one, just write the number, I will get to know. Third number, then fifth number, sixth, seventh, how much you got, and all the unit is u, unified mass. Okay, not in a gram, because we have to not find the gram molecular mass. Okay, so this is for the today's video. Thank you, bye bye, take care.